For this section, we're looking at expanding and condensing each logarithm. Before I begin these, I want to do a couple of changes to some of these problems to make them a little bit easier for us to process. The first is I'll change the square root to a 1/2 exponent. So I'm going to rewrite this as log base 6 of VW squared u to the 1/2. And the second is on number 4. I'm going to write the things that are divided by 2 as times a half instead. So log base 8 of d plus 1/2 log base 8 of a plus log 1/2 log base 8 of b. And again, that's just to make this look a little bit easier. It means the same exact thing, but that lets us work on these a little bit faster. All right, for the first one, I'm also going to distribute this exponent. So it's x cubed. 3 times 3 is 9. Z cubed, so I don't have to deal with that on its own. All right, I'm going to do the shortcut method for this. I'm going to bring the 3 down in front. Log base 5 of x. We're multiplying, so this is going to be plus. Bring the 9 down in front. Log base 5 of y. We're multiplying, so it's going to be another plus. And then that's going to be z cubed, so I'm going to bring the 3 down, log base 5 of z. At this point, the problem is done. For the next one, all things are being multiplied, so I don't have to worry about any kind of subtraction stuff. And I'm going to do exactly the same thing. We've got log base 6 of v, bring the power down, 2 log base 6 of w, bring the power down, 1/2 log base 6 of u. At this point, that problem is done. For condensing into a single logarithm, I'm going to set this up as one big log, and this will be log base 3. And I've got a fraction going on. Positive stuff's going to be on the top, negative stuff's going to be on the bottom. So we're going to have on top x, and that 4 becomes the exponent to the 4th. On the bottom, we're going to have z, that 4 becomes an exponent to the 4th. And y to the 24th. At this point, the problem is done. Same thing for number 4. We've got log base 8. I'm going to set up a big thing with a fraction. Anything that's positive is going to go on top. Anything that's negative is going to go on the bottom. Hey, all 4 things are positive. So we're just going to deal with multiplication. So we're going to have c times d times a to the 1/2 times b to the 1/2. At this point, the problem is done. Next up, we've got some right triangle trigonometry stuff. And here you're asked to do some reasoning here. We have an idea that sine of alpha is equal to cosine of 90 minus alpha. And we're trying to figure out why that's true. So let's make a triangle. And I'm going to call this alpha. And if this is a right triangle, we've got to add up to 180. Let's figure out what the third side is. So I'm going to call that dot is equal to alpha plus 90 for the right angle. And I like that I did an equals there. So let's plus that, and that's equal to 180. Very quickly, we arrive that that dot is equal to 90 minus alpha. So I'm going to write that as 90 minus alpha. Okay, I'm going to call the sides x, y, and h, just to kind of talk about horizontal, vertical, and hypotenuse. And if sine of alpha is going to be y over h, cosine of the angle that's 90 minus alpha is going to be the adjacent divided by the hypotenuse, which is y over h as well. So what we've shown is that in this case, sine of alpha and cosine of 90 minus alpha mean the same thing. That's actually why it's called cosine. What cosine stands for is the sine of the complement, so the sine of the angle that adds up to 90 with the existing angle. And they shorten that to make cosine, and that's why that relationship happens, which is kind of a cool thing. All right, then we've got to show that sine squared plus cosine squared is equal to 1. Okay, we don't really have any thing to go with here, so let's call this x. I'm going to call this my opposite. That's an O, not a 0. That's going to bite me, I think. and my hypotenuse. All right, I know that a couple of relationships are true. One is that opposite squared plus adjacent squared is equal to hypotenuse squared. And we also know that sine of x is going to be opposite over hypotenuse, and that cosine of x is going to be adjacent over hypotenuse. The other thing that we have to talk about briefly is that this notation means the same thing as sine of x squared. We put the squared above the sign so that we don't get confused between that and sine of x squared. Since we're not great at using parentheses all the time, this notation was decided as a standard to kind of avoid some of that. So if I wanted to find sine squared of x, we could say that would be o squared over h squared, and cosine squared of x would be a squared over h squared. Okay, so now let's take a look at this. If we've got sine squared plus cosine squared, that's going to be o squared over h squared plus a squared over h squared, which, if I add the fractions together, we get o squared plus a squared over h squared. And I'd like you to notice this relationship. So the Pythagorean theorem tells us that o squared plus a squared equals h squared. So we really have h squared over h squared, which is, of course, 1. Kind of a weird thing. All right, then we got some problems to work on. This one, we're given a picture, which is kind of nice. And we're told that the angle of the elevation to the top of the building is 50 degrees, and the angle of the elevation to the top of the tower is going to be 60. We're trying to figure out how tall the tower is on the roof. What I see here are two separate triangles. We've got one triangle that has this 100-foot thing and a 50-degree angle. That's going to give us this height of the building here. And then we find the other triangle, which is the 60 degrees. That's going to give us the height of everything together. We can probably use that to figure out how high that tower is on its own. So let's do some math here. So thinking about how we're setting this up, we're looking for the y. We have the adjacent. That looks like an opposite over adjacent thing to me. So I might start this off as tangent of 50 is equal to y over 100. So 100 tangent of 50 is equal to y. When I do that calculation, I get 119.175 feet. Cool. Now we're going to do the same thing, but we've got to figure out what the total height of the tower plus the, I guess, the tower on the tower. Okay. And I'm looking for this whole thing. So that's an opposite thing. I've got that adjacent again. This is another tangent. So tangent of 60 is equal to, I'm going to just call this the height over 100. Okay, so 100 tangent of 60 is equal to that height. When we do that, we get the height is 173.205. When I subtract those two to get my actual tower height, that's 173.205 minus 119.175. I get 54.03. All right, so now we've got a problem where we're looking at two girls standing 100 feet apart. So there's one, there's the other. They both see a beautiful seagull in the air between them. Try to make that a little bit off center so it didn't feel exactly in the middle. And then we've got 20 degrees and 45 degrees for angles of elevations. All right, so we've got to figure out how high the seagull is. And to do this, we're going to have to rephrase the stuff on the bottom. Because on the left, let's say I called this x. That means that the bottom part on the right would be 100 minus that x. Okay, So we're trying to do some trig. We've got stuff about the opposite and the adjacent. Again, this is going to be another tangent function. And what I can say is that tangent of 20 degrees, this is the left triangle, is equal to h over x. I'm going to get h by itself. That's going to be a little bit easier for us. So we get x times tangent of 20 is equal to h. The reason that's going to be easy for us is we're going to get the same h in the next problem and combine those into one equation. Okay, let's take a look at the other side. Here we've got tangent of 45 degrees is equal to h over 100 minus x. Cool. I'm going to multiply that through, so we get tangent of 45, which, by the way, is 1. And we get 100 minus x is equal to h. The good news is now we have an h on both sides of this problem. We're going to combine these two into one equation. X times tangent of 20 is equal to 100 minus x, the two things that h is equal to. I'm going to do a little bit of math now and get tangent of 20 is going to be 0.36. So we get 0.36x is equal to 100 minus x. If I add that x to the side, we get 1.36x is equal to 100. Dividing 100 by 1.36, and we get x is going to be 73.53 feet. Unfortunately, that's this part, and that's not what we were looking for here. So 73.5, I'm just going to leave it as a tenth. I do know how to find that h based on that, and I'm going to work that back in. So we've got 73.5 times the tangent of 20, and that's going to give us h. I could also do 100 minus x is equal to h, and that may be a lot faster. That's going to be 26.5 as our answer. But just to confirm, so we've got 73.5, and we're doing that times the tangent. Oop, I just divided by tangent. There we go. Tangent of 20. And we get the 26.75, which is a rounding thing that's going on there. So I blame myself for that because of rounding stuff. I keep erasing things I don't mean to be. So 26.5, 26.75. There's some rounding differences there. Either one of those would be a correct answer for the this problem specifically. All right, next up we got some law sines and cosines things. Here we've got a shed that has vertical walls of equal height. That's going to be important because that means I can draw a line across that's going to meet at both of those. So we've got 15 feet because these are going to be nice vertical walls. And we've got to find the measure of the angle between the two sections of the roof. All right, this looks like a great problem to, A, we're not doing right triangle trig here because it's not a right triangle. It also is not in that section. Hint, hint, hint. B, I don't know any opposite pairs of information, so law of sines doesn't make sense. This is a great example of a law of cosines problem. We know we're going to need cosine of that question mark. We know that the opposite thing is going to go by itself. And then I'm going to just build the rest of this. So 5 squared plus 12 squared minus 2 times 5 times 12 from the other pieces. When I do these calculations, so we get 225 is equal to 25 plus 144 minus 10 minus 120 cosine of question mark. Moving these things to the other side, 200 and then minus 144 is going to be 56 is equal to negative 120 cosine of question mark. Dividing that by 120, we get 56 over negative 120 is equal to cosine of question mark. The inverse cosine of that is going to give us our angle. If you were doing this on a quiz, you could leave it like this or get the answer in terms of that angle, which is 117.818. All right, here we've got a satellite dish, and we've got a problem where we're trying to figure out what's going on with a jet. And we've got an angle, we've got two sides. I don't see any right angles, so this is not right triangle trig. I don't have opposite information, so this is going to be another law of cosines thing. The first thing I've got to do is to figure out this distance so I can then figure out the average speed. So let's do that. That's what we're trying to figure out. So question mark squared is equal to 58 squared plus 35 squared minus 2 times 58 times 35 times cosine of that angle, 132. This is one of those beautiful ones. You can type that whole thing in on a calculator. And when I press enter, I get 7305.67. Taking the square root, we get 85.47. But that's not the end of this problem. We have to find the average speed. So we're going to take this distance and divide by 0.25 hours. So 85.47 miles, 0.25 hours is going to give us a value in miles per hour. When I do that, I've got 341.89 miles per hour. The other piece of law of sines and cosines is talking about that ambiguous case in law of sines. So you might guess that's what we're looking at here. Let's draw some triangles and see what happens. So you've got triangle FDE. We're told F is 80 degrees. E is 8 centimeters. F is going to be 11 centimeters. So when we're trying to figure this out, we know this is going to be law of sines. I have some opposite information. And I'm going to set this up to figure out what E could be. And when I do that, we end up with sine of 80 over 11 is equal to sine of question mark over 8. The other piece of information that I see here is that if this is 11 and I have an 80-degree angle here, the fact that I have a smaller side opposite the question mark has to also be smaller than 80 degrees. That's kind of a cool thing for us to notice because that's going to take a little bit of work out of this problem. So assuming that these numbers work in this triangle, this should give us a chance where we don't have to look at both of those possible values. So we end up multiplying by 8. And the value for that is going to be 0.7162 is equal to sine of question mark. The inverse sine of that and when I do that is 45.7 degrees. Now, here's where this comes into play. So the other angle we would have to consider would be 180 minus that 45.7, which would end up being about 134 degrees. Since we know question mark has to be less than 80, the only angle we can use is 45.7, and that gives us a number that works to get D as well. So we only have one possible triangle for number 9. For number 10, let's do that same thing. So we're going to do y, z, x. We've got 42 degrees. Opposite that is going to be 24. Opposite the x is going to be 25. I'm going to start the same way. I've got a pair here, and I'm looking for the angle for x. So we're going to have sine of 42 over 24 is equal to sine of question mark over 25. Multiplying that 25 across, and we get 0.6970. If I take the inverse sine of that, that's going to give us our first angle. And that first angle we get is going to be 44.18 degrees. My first check is that that's bigger than 42. 25 is bigger than 24. So we are okay with that. That's also going to give us a value that would let us find an angle for z. So we're also in good shape there. Let's find out what that other possibility would be. The other possibility here would be 180 minus 44.18. And if we do that, so 180 minus 44.18, that's going to be like 136, 135.72. That means our third angle, z, would have to be 180 minus 135.72 minus 42. And that works. That's going to come out to be a really small number, like 4 degrees. In fact, I think it's 4.18. Nope, even smaller. I forgot about the 42. It's going to give us like 2, I'm out of eraser, there we go, 2.28 degrees. That's a really small angle, but that still is an angle that works. So there are 2 triangles possible here. One with the 44.18 degrees and one with the 135.72 degree angle for x. All right, dealing with angles in a circle, we got to find some reference angles. And first up, we got 150 degrees. That's going to go almost to 180, and I need 30 to get there. For 210, that's going to go past 180, but not quite to 270, and I would need 30 to get back to 180. For negative 120, it's going to go past negative 90, but not all the way to 180. And to get from 120 to 180, I need 60 to get there. And for 320, that's going to go almost all the way around, but not quite, and I need 40 more to get to 360. For the next part, finding reference angles when dealing with radians. So here we've got negative 13 pi over 12. I know that if I were counting in pi's over 12, going halfway around would be negative 12 pi over 12. So negative 13 pi over 12 would be just past there. In fact, it would be exactly 1 pi over 12 past that point to get to that value. For 5 pi over 3, I know that 3 pi over 3 would be 1/2 of a circle, because that's 1 pi. So I need 2 pi over 3 left. That's not quite all the way to 6 pi over 3, which would be 2 pi. You notice that I converted these measures into the same over 3 thing. Finding common denominators is a really good way to begin to find reference angles with radians, and that helps us kind of see where these things are. To get from 5 pi over 3 to 6 pi over 3, we have pi over 3 left over. And then finally, we've got negative 7 pi over 9. Again, I'm going to convert these into pi's over 9. So I'm going in the negative direction. Here would be negative 9 pi over 9. For negative 7 pi, we're not getting quite there. So it's like we're getting most of the way there, but we have 2 pi over 9 left to get from 7 to 9. That would be my reference angle there.